This time we'll deal with some different data, fundamental data, sentiment data, and so on. I should say that with the new sentiment data, we did try a vendor, and it was quite expensive for us. And after a significant amount of effort, we discovered that there were all sorts of problems with their data. So when this Kaggle 2 Sigma news features competition came along, we decided that 2 Sigma should have access to the highest quality data. And in fact, they did. And it was Thomson Reuters news sentiment data that they had in the competition. So the first notebook that I have on this is, or it shows a sample of the data from this 2 Sigma competition. Let me say again, the overall theme here of these first 2 days is data is a lot of work. There are all sorts of problems. And as painful as it is to really look at the data, you'd better do it. Otherwise, essentially, your results are likely to be worthless. So 2 Sigma, a large hedge fund, sponsored this competition to extract predictive signals from data they supplied. And let's talk a little bit about the data. It's not possible in the competition to download the data yourself because of those data restrictions and the very high cost of that data. So this actually gave us an opportunity to play with this data and to check out how predictive it was. Now, there are certain things about this competition that made it less predictive than you would want, and we'll go into that later. So there are 2 parts to the data. The data is from 2007, the beginning of 2007 to the present. The market data provided by Intrinio, but the news data was provided by Thomson Reuters. It's a kernels only competition. Now, if you don't know what Kaggle is the leading competition site for machine learning. And a lot of companies put up competitions to solve very real problems that they themselves don't have the resources to address. The classic is Netflix putting up a recommendation competition that saved them billions of dollars. So the market data we're really not going to address, except there's 2 things here. There's an asset code, which is a unique ID of the asset. It's basically the ticker symbol. An asset name turns out to be the company name. One important thing about the data that they provide here is that they have the usual close open in this case because it's daily data, but they provide these res examples, and they're residual closes or residual returns. So what that means basically is that they have taken out the market beta. So it's essentially the market itself has been removed. And so you essentially have overperformance or underperformance on these relative to that. The news data. So the news data has the actual key for the news data is the asset name. In other words, the company name. Companies can have several different tickers, as we've seen with Google. But the news stories will have reference to quite a few companies or just one company. What they did with the data is that if a news story contained references to multiple companies, then they added a line for each company to the data, making the data the key in the news, the actual company name. So there's a number of things which are numeric and a number that are categorical. So something like the provider, which would be Reuters or BSW, is a category. Subjects, topic codes, another category. Then there's numerical ones, just the body size, the number of companies mentioned in the article. Then there are numbers that they derive, something like relevance, whether the sentiment is negative. So obviously these ones here require natural language processing that they apply. And when a company does this in providing the data, what you want to be sure of is that they don't change the process that they use in the middle. We're assuming that Reuters doesn't do that, but that's exactly one of the problems we ran into with the vendor that we tried. So let's just have a quick look at this data and just illustrating some of the techniques that we use to look at the data and start processing it. So in the market data, you'll notice the times here are all at 2200 UTC, which is either the close of the market or an hour after the market, depending on daylight savings time for the East Coast. So they're all at a fixed point. The competition had you predict the 10-day residual return, the residual return from now until 10 days in the future. And you had to buy or sell at the open of the day following this time. Okay, the news itself, that's all those fields that they showed there. Actually, it's a bit difficult for me to scroll and see the headlines, but if we go way over here, then you can see all these different things. Novelty count is basically inversely proportional to the number. In other words, the novelty count of 7 means that it's not very novel because it's been mentioned already in 7 articles. Okay, so here's the size of the sample that we're loading, and there are only 100 lines, but in fact, the market data that they provided had 9.3 million lines. So there's an average of twice the amount of news data than market data, which is kind of interesting because every stock has a price each day, but not every stock has news each day. So part of the compounding effect is just the one I mentioned before, that they broke it into a line for each company. So a single news article can provide you with multiple lines, and we'll just see that in a moment. So one organizing principle here is just to use a class. There were so many different things that we had to look at. It was convenient to create a class. Normally you would have the methods all included in this, but we just simply add the methods as we need them. So for a production thing, you would in fact have all of those methods already in place. So, as I said, each asset name, meaning each company, can have several news items per day. So several rows in the data for an asset name on a given day. On the other hand, the market data has only one entry per stock per day. So in order to merge the two, we have to make sure that essentially we get a single item per company per day in the news. So we have to aggregate. One of the aggregations is to add a new thing called news count, namely the number of times, the number of articles that, or number of lines that appear for that company on each day. So doing this, and scrolling to the end again, we've added news count, and in this example, there's at least in the head here, there's only one per company that appear in the head. We believed, and it turned out to be the case, that the relevance and sentiment were the most important features. But notice that they have a very interesting approach to this. The relevance has to do with whether it was in the headline or not, whether it's emergency alert and so on. But the sentiment class is the predominant sentiment class, and these are the three that they have: negative, neutral, and positive. So the probability that the sentiment of the news item was negative, probability that it was neutral, probability that it was positive. So how do you deal with that? Well, the way we chose to deal with it is we just created a single feature called sentiment. So it's 0 if neutral has the highest probability, minus the negative value, the probability of it being negative, if that's the largest, and positive otherwise. So the relevance, so for instance, if it was highly positive, but the relevance was minute, then of course it doesn't carry the same weight. So we chose to create the rel cent, which is basically we take the sentiment value, right, which is positive. It's negative through -1 through 1, times the relevance, and then just divide by the novelty count, essentially, because that sort of unweights it. If it's mentioned a whole lot of times, it's not very novel, and so it sort of unloads the weight. Now, you can choose many different ways to approach this sort of problem, but this just happened to be the one we chose, and we tried several things, but it's just our way of dealing with it in this case. So let's just operate to see what we get for this sort of thing. Well, the sentiment seemed to be pretty negative for these ones here, and here's the weight version. So how do you aggregate the numerical features daily? Now remember, we're aggregating because the market data has only one line per day, so we need one line per day to do a proper merge. So there are all sorts of ways, and in this case there are we look at sum, mean, max, and min. So there are all sorts of different ways to do it, and you can do them all at once. And unfortunately, since we have such a small sample, there's some not terribly interesting stuff going on here. Then, additionally, you want, or we wanted a feature that was a rolling mean across a number of days, since they, in fact, have a lot of data that are means over those days, or so they had 1 day, 2 days, 5 days, 7 days, and so on.
Yes, Walter, you see Frank's question?
Yes, certainly. Well, you're the one that knows the prices of these things.
Oh, okay. Yes, the data that we purchased previously is from CERN, ACCERN, and that was, I think, at that time we got a special deal. It was about $20,000 to $25,000 a year.
And I think for the Reuters data, it's much higher than that.
Yes, but I no longer remember what the quote was. I think, oh yes, I think the Reuters data is from $5,000 to $7,000 per month.
So the fact that they can charge such large numbers seems to imply that there's real value there. And we've heard stories of people doing very well with it, but also we believe that a lot of that value is gone now with enough people looking at it. So with the categorical features, what do we do with those? First of all, we need to make them numeric in some form. And actually, even before that is the fact that they're actually in the data with strings like this. So they're just a single string, but clearly they're individual ones. So audience is an example. And that, as you saw above, it's the actual place where they appeared, for example. So let's just look at the audiences here. And already you can see that these three are most likely 3 lines from the same article, just 1 line per company added. Let's just check, get the unique audience groups. So in the data that we have, there are 39 unique audience values. Here are the first 5. Every one of them actually has a value count. We'll look at the frequencies of them. So, actually, yes, it's in the frequencies. So, remember that there are 100 lines in this data, and the audience E appears in 80 of those lines, PSC in 79, and so on, down to D with 29. And obviously there's going to be let me look at the last part too. Whoop, what did I do? Copied incorrectly.
Chen, I asked a question about what are these audience features? What do they mean?
Okay, well, let's go up to where it's explained in their own terms. I'll go right to the top of the... Okay, where's the audience here? News data. Let me find it. Identifies which desktop news products the news item belongs to. They're typically tailored to specific audiences. M for Money International News Service, FB for French General News Service.
And of course, it's specific to the Reuters newsfeed. This is Reuters data, so right. they have this different like category of audience and who is subscribing to what newsfeed, and that's only relevant to that if you are a Reuters subscriber.
Right. So let's just plot the occurrences. This, I'll just show you in a moment what happened in the real, with the real data. Oop. So the first thing to do in actually converting this data for use in a model is to tokenize. So in other words, we've gone from a string containing these inner strings to an actual list with individual tokens. And in this case, I'll explain this in a second, but in the real competition data, we had to restrict the number because the number of audiences meant that the data became so large that there was no way to process it within the kernel size that they allocated for us. So we used the multi-label binarizer. I believe there's now a new version that actually, it's talking about binarizing labels rather than binarizing the actual data itself, but of course it works either way. And I believe there's a replacement for this. There's essentially a one-hot encoding for the data, which for multiple, so for items that contain, see, if you just have a single value, one-hot encoding is already, or was already implemented for pandas. But for the multiple ones, the multi-label binarizer happened to be the only way to do it that we found anyway. So we'll just look at. So what we do is also aggregate now. And in this case, we're just taking the sum. In other words, we've one-hot encoded a column for each of the audiences. But then remember, there are multiple rows per day for individual companies. So we're just summing those up. You could take just the existence if you wanted, and so just have a 0 or a 1.
Let me do a poll right here. Is anyone not familiar with the concept of one-hot encoding? Please raise your hand if you are not familiar with that concept of one-hot encoding data, categorical data. Okay. So, Roger, maybe you can explain what one-hot encoding is.
Yes, well, basically, if you have a number of categories, then you want to just indicate for that row whether that category is present or not. So you just have a 1 and otherwise a 0. So you have to have a vector that is the length of the number of categories you have.
That's right. You have, for example, a categorical feature that has 3 different distinct values, right? If you have 3 unique values, one-hot encoding that one feature will turn into 3 different features, but each feature will now have only 0 or 1 as the value.
Okay, so this is actually the result of a real run with the competition. I should say, by the way, these kernels are free. If you just sign up to Kaggle, create yourself an account, you can still go and play with this competition. All the data is still there, or you can do any other competition or look at the others, and you have a free machine that is also set up with a GPU if you want. In fact, they specifically blocked us from using a GPU in this competition. I'm not sure why, and so a certain number of people actually tried or did neural networks with it the hard way, if you like. Okay, so I will just, sorry about a bunch of scrolling through this thing here, but I wanted to, actually the only thing I really wanted to show you is that when we, this is, let me see how many there were. You can see the sort of counts that we had for audience. So E was 6,780,000 of the 9.3 million rows. It drops off fairly quickly, as you can see, the count for each one of them. And I forget how many there were, but there's at least, looks like 180 or so. And then with the training that we did, sorry about this movement, but I just wanted to show you the feature importance we got. So here's our rolling mean that we did, and the sum that we did for each day. And you can see that the sentiment was far more important than any one of these individual audiences. And in fact, as I think I mentioned in the notes on this, the notebook, we saw no evidence of anyone really gaining any extra predictive power, or if it was tiny compared to the market data. Now, a lot of that, I think, or we think, and Ernie has a blog post on this, and I'll just point you to that for a second here. So it's epchan@blogspot.com, and if you look at it, the title is News Sentiment Still Adding Alpha? And it actually describes the story of our work on this. And the conclusion is that, well, amongst other things, you're having to trade, well, at least a day or certainly overnight after the news announcements appear. So there's many hours delay, and there may well be value in news if you act extremely quickly. And I'm sure that's still the case to some degree. But for things that apparently worked earlier, there was also some suggestion by some people that 2 Sigma was really presenting this competition as a recruiting tool to see if they could hire the people who were most successful in it. There's no way we can verify that easily. Okay, so that's our experience with news sentiment data.